Before I get to the lesson,
Wait.
before I get to the lesson, there's two things I want to talk about in terms of homework that I just graded or I have been meaning to talk about. First thing is, gosh, I just lost on that average value. This is page 2. I noticed this. If you have it in front of you still, you might write yourself a note. But finding average velocity can be done two different ways based on what you're given. Okay? If you're given velocity, then to find the average velocity, then it would make sense to do this, yeah? You with me? Okay, now that's what most people did, and that's logical because it was fresh on your mind, so cool. But if you're given position, about half of the people said, well, I know to get average velocity, I have to first, I want to do this thing here, so I first need to start with position and find x prime for the velocity. Then, once I have the velocity, then I can do 1 minus a of that velocity, and boom, I'm good. Now, do you see what you just did? You said, oh, okay, I'll take the derivative so that I can take the antiderivative. Huh? I mean, wake up a little bit, okay? So that's ridiculous. If you're given position, you've actually been doing that problem since the first day of this class. The average velocity, besides being average value, is also change in position over time. And if you have position, that's what you should do. To integrate, or to take the derivative, then integrate, is ridiculous and a waste of your time. Now, if you're thinking, wait a second, I don't even understand, how can this average velocity be two totally different things? Is it? What is, if I do this, what is the antiderivative of v? X. This is exactly what we've always been doing. The change in position over the change in time. It's the same. But if you're given position, why do the derivative and integral? That's a colossal waste of your time. They're throwing you a bone. Take it. Okay? So you need to think a little more first before you plow ahead. Velocity, average velocity can be done two totally different ways based on what you're doing. Are you with me? Okay. Second thing is I'm gonna have to put this on the homework because it's freaking gigantic. Say you want an antiderivative. Let's say you wanted an antiderivative of motion. X given a velocity and an initial condition. All right? This was on the test and people mangled it. All right? Just to remind you, there are two ways to use an initial condition. All right? If I said I want x at t, I could say x initial plus the change from 0 up to a certain time of v. That is true, and it works, though you may not leave it there. You must integrate. I also could say x is the antiderivative of velocity, get the antiderivative without limits, which would mean I'd get a plus c, then I use my initial to find the plus c. Now, done properly, these should be the exact same answer, an x function of time. Are you with me? Are you with me? Okay, what absolutely 100% is not true is this. To say that x is the initial condition plus a generic antiderivative with no limits, not true. No. Okay, this is not the constant. that is garbage. If you think that you integrate and the initial is all we see, it's not, it's not, it's not. Do the work properly. I think you're starting to bleed two ideas into each other. You're either doing the initial plus a definite integral from 0 up to some time, or find the C. Don't mix them, please. All right. Today's lesson, yay, here we go. Indeterminate forms, part 2. You have indeterminate forms are limits whose answer cannot be determined without more work or more investigation. Okay, so far we have done these two indeterminate forms. Limits that come out infinity over infinity, that's indeterminate. It's most definitely not 1, right, Jasper? Because infinity, infinity are not numbers. They are ideas. To say that that is 1 is ridiculous. It would be like saying love divided by democracy is 1. It's ideas, not numbers. So don't treat them like numbers. It's ridiculous. Same with 0 over 0. It is an indeterminate form. It matters how fast they go to 0. And to get into how fast, we use, this is where you speak, L'Hopital's rule. We take derivatives to compare their rates at which they go to 0. Which one goes to 0 faster? If the top goes to 0 faster, well, then it might get small. But if the bottom goes to 0 faster, dividing by small gets large. So we talk about rates, right? Right. Okay. Today is a different type, actually 2 different types of indeterminate forms. Infinity minus infinity. Is it 0?
No.
Yay, good answer. It is not 0 necessarily. Consider this question. Joe runs east forever. Mookie also runs east forever. What is the difference between the 2 positions approach as time goes on? What is the distance between them start to approach? What? Infinity, you say?
No, 0.
0, you say?
No, we don't know.
Yeah, you know, that's the right answer. What if they run the exact same rate? Then the distance between them would stay the same. But what if one person ran way faster than the other? Then the distance would approach infinity. So this is an indeterminate form. The rates at which they go to infinity matter. So then the obvious question is, so should I take the derivative of each and subtract to look at the difference between their rates, or compare rate 1 versus rate 2 or something like that? Now, that would be logical to see which one goes faster. Let's take their rates, which means derivatives, and then see does it come out positive or negative. Now the problem though is A minus B always positive or always negative, or kind of varies? It kind of varies, okay? The problem is that adding and subtraction problems don't have hard, fast rules for whether they get big, small, or what. So instead of keeping that a difference, we actually are going to compare rates. This is a no. We want to make it a ratio of their rates, because ratios do have hard, fast rules. First of all, we can use L'Hopital's rule. Second, positives divided by positives are always positive, and negatives divided by negatives are always negative. So it's better to make it a quotient and look at their rates. So that way we can make it more like a L'Hopital, right? You never use L'Hopital. You never take a derivative on the original problem. You will get wrong answers that way. So let's take a look at this. This is an example of what you might see. The limit of, as x goes to 0, does that say from above? I can't see that. Is that above on the positive side? Okay, positive. Thank you. So, what about cosecant? Isn't cosecant the reciprocal of sine? And so if sine looks like that, doesn't cosecant look this way? So as x goes to 0, cosecant goes to infinity. Cotangent, that one's a little grosser, but I don't know if you remember your trig graphs. Could you graph cotangent if I made you?
Yeah.
Okay. Cotangent looks like that, and it also goes to infinity. Now, how this difference would come out would kind of depend on the rate at which each one goes to infinity. So if this is an indeterminate form, and we need to figure out the rates and the rate at which each one goes, then we make it a quotient first, so we can compare in a ratio form the rates. To make this a quotient, sometimes you're going to have to do a little bit of rewriting. For example, this is 1 over sine and cosine over sine, yeah? And so I could rewrite this and make it a ratio problem by calling it 1 minus cosine over sine. Now it starts to be familiar territory, I hope. This is L'Hopital work, and I expect proper L'Hopital work. Proper L'Hopital work is justifying the use of derivatives before you take them. So what does 1 minus cosine of x approach as x goes to 0? It does approach 0. And as x goes to 0, what does sine approach? 0. And so by L'Hopital, it is appropriate then to find, or instead look at their rates of change and compare those. 1 minus cosine x's derivative is negative, negative, so positive sine of x, and the derivative of sine is cosine. That then, can be evaluated. The top goes to 0, the bottom goes to 1, so that is 0. The limit would approach 0. If I made a table, or if I looked at the graph of this crazy mixture, whatever that might look like, it would approach 0 as x got closer to 0. You follow? Try these two on your own. I want you to check indeterminate first. Okay? Try those. And we'll go over it. The only way you get good at these is by practicing yourself. Start by plugging in 0 and seeing what happens. So if x goes to cosine, or into that, and what's cosine? Cosine 0 approaches 1. Okay, so that is the denominator is 0, and 1 over 0 is infinity. And it goes in 1 over tiny, don't think 0 so much as 1 over tiny numbers. 1 over tiny numbers are huge numbers. I'm not asking you to succeed, I'm just asking you to try. And I should say, is that a small negative or a small positive? This is might be something my work might look like. What is cosine approaches, x approaches 0? 1, okay. So what about negative 1 plus 1? Is that's approaching 0. Is it approaching 0 from the positive side or the negative side? I disagree. Okay, cosine is a little less than positive 1, and negative 1 plus a little less than positive 1 is, which one's bigger, the negative 1 or the cosine? Negative 1. So that is actually small negatives, and so that would approach negative infinity. The second one, as x approaches 0 from the positive side, that's 1 over small positives. 1 over small positives is big negatives. Now then, is that I don't know? No, I know. Negative huge numbers and another negative huge number is not I don't know. I know. What is it? Negative infinity. That is not a L'Hopital nor an indeterminate problem. It's not indeterminate. I can determine it. It's negative infinity. Now you do have to do a little bit of thinking. That part is the hard part for students who get better at it. That's the thought process. Some people write small positive, small negative. That's fine too. Okay? Try the next one. Which I believe should be indeterminate. Okay. Hopefully you're finding that you put it together to make it a quotient. You do not take derivatives when it's a difference or sum. So you put it together to make a quotient, and it is a 0 over 0 L'Hopital case. Derivatives require a little more work, but you're big calculus students now. You can handle it. Either way, you're going to have to do the product rule. So first is the same. I hope after L'Hopital once it goes well. What do you get? It's not indeterminate anymore. What does the top go to? 1 and the denominator? That's 0 and small positive or small negative. Do you agree this is 0? Okay. Negative 1 plus this is going to approach positive 1. So it's going to approach 0, but I definitely need to figure out which direction. Is this cosine going to be more than 1 and therefore greater than the negative 1, or a little less than 1 and therefore the negative would win? Little less, all right. So this is going to be 0, but from the negative direction. So 1 divided by small is negative infinite. Okay? All right. Other indeterminate form. Okay? Now, the other indeterminate form of the day, there are actually 7 indeterminate forms. 4 of which you'll learn in this class, and 3 you'll learn in Calc 2. There are exponential indeterminate forms we'll talk about later. But when I say it's infinity times 0, it's really, you should have in your mind approaching infinity times approaching 0. Surely, if I give you this problem, the limit as x goes to infinity of x times 0, that's not indeterminate. It's 0, period. There's no indeterminate to it. Okay? But if I gave you something like the limit as x goes to infinity of x times 1 over whatever, e to the x, that then is a little different. That's approaching 0 and approaching infinity. Okay, so the point is this then. It's indeterminate because it would matter which one grows. Does the big guy win or does the little guy win? It matters what the rates are. So again, do not, do not compare the rates, or do not take derivatives the way it is. Instead, make it a ratio. There it is, that's important. Make a ratio first before you do any L'Hopital work. You want to compare their rates of change. All right? So, this is a bit of a, let's actually make sure it's an indeterminate form. As x goes to, or as t goes to, oops, this is bad. This should be t goes to 0, sorry. As t goes to 0, what does sine t approach? 0. And what does log of t approach? Here's the graph of log. As you get closer and closer to 0, what does the y value approach? Negative infinity. That is an indeterminate form. Smaller times really big. Which one wins? I don't know. That's why we have to investigate further. So the question will then be, all right, well, which one do I want to put in the denominator to make it a ratio? You must make it a ratio first before you ever do any comparing of their rates of change. Do not take the derivative on the original form. You must make it a ratio. All right, so let's go. Natural log I could put down with a negative exponent, but I think it'd be easier to put sine down and just call it cosecant t. You down? Yes, you agree with me. Okay, so now, getting into my L'Hopital work, the limit as t goes to 0 from the positive side of log of t, what is that approach again? Negative infinity. Cosecant, the limit as t goes to 0 from the positive side of cosecant, that's 1 over small, right? Sine goes to 0, so 1 over small positives is big positives, and so that is an indeterminate form. Don't worry about the negative. Any form of infinity over infinity, when you're talking dividing by, is indeterminate. So by L'Hopital, we can instead compare the limit of their derivatives. What is the top derivative? 1 over t, and the bottom derivative? A little rusty. Negative cosecant t, cotangent t. All right. Now this is such a mess that I'm not going to try and do the limit yet. I'm going to clean this up. The limit as t goes to 0 from the positive side. What can I do to clean this up? Put them in. I put these in the numerator by taking the reciprocal functions. So can I call it negative sine t tangent t in the top, and then times 1 over t would be over t, eh? All right, this is your favorite. What do I get as an answer? Still indeterminate, correct. I know how you love that. So now we need to do, again, sometimes you do L'Hopital twice. Get over it. Negative sine of t, tangent of t goes to 0. The limit as t goes to 0 of t goes to 0. So by L'Hopital again, the new limit is product rule. Give me the derivative in the top via product rule. Negative sine of t times secant squared t plus tangent of t times negative cosine of t, okay? Over 1. So at the very least, we wouldn't have to keep doing this much. What does sine of t go to? 0. What does secant of t go to? Given that cosine looks like this, secant is 1. Tangent of t goes to 0, and cosine goes to negative, I guess it is negative 1 because of the negative in front of that, right? So overall, the limit is 0. Yay. All right, that is the idea. Try this one, please, and then we'll go. I think that's sufficient. If you Do you feel like I'm not gonna even check and determine it first, I'm just gonna make it a quotient, then check and determine it? I'm actually okay with that. Students often say, you know what, I'm just gonna read right away that it is a quotient. That's fine. You know, it's tempting to use end behavior here, but if it's a L'Hopital problem, we just show the L'Hopital work. Actually, so you're probably thinking, do I really have to do all that L'Hopital work? How many L'Hopitals might I have to do? Couple, right? Two, maybe even three. Or can we just use end behavior? I'm trying to think of an AP question like this where you could use AP. They wouldn't make it the AP question an end behavior question. I would be okay if you used end behavior. What is this equal to? Which one wins, E or the cube? E. And so if the denominator grows bigger faster, smaller over really, really big, does it go big or to 0? I'm okay with that. Let's not check our thinking at the door, right? You don't have to always jot everything out. Questions on set 90? 90? Do you have 2 homeworks? That sucks. 90. 91, 6, 4, and 20. What? 20 and 15. I might have to collect both today and go over more questions tomorrow, but I don't want to get behind. 16?
No, we also need 16. Oh, also 16.
What? You said it's not 15 and 16. What? Me too.
Do we have full?
15 and 16?
Yeah.
I don't know. Let's see. It is here. Also, we did test credits, which you'll have to do in class. Um, so, you might have to take a double. What's that? 13? Okay. 13. Where's my book? Oh, not 13. Number 1. Question on 1. Is it replaced in any way? It is.
No.
Okay, 1. All right. Related rates review. This is height. This is 4. Okay, hopefully you got the given. Water is dripping out, so negative dVdt is negative 1.5 cubic centimeter per second. And they want dH/dt when h is 2. Okay, did you start with the volume equation? What is it? 1/3 r squared h. Okay? Volume is 3-dimensional. Between r being squared and height being there, that's 3 dimensions. All right, so you don't want to differentiate that on 3 variables if you can do it. So the other fact you should substitute is using similar triangles. If you look at a cross section here, the relationship between the radius and the height of the water will conform to the dimensions of the cup, which is 2 to 4. From that you can see that the radius or height rather, is twice the radius, yeah? Or the radius is half the height. I could use either one of those facts in there. It's up to you what you use, but given that you want dHdt, it seems logical to dump R and keep H. So V is pi over 3 times H over 2 going in for R, which needs to be squared. So use an equation of volume is pi over 12 H cubed for your equation, and then differentiate that with respect to time. You should be good after that. If you're not, come in. 6. Is 6 still a question? You did 6 still?
Yes.
Okay. 6. Average height when it's dropped 576 feet. Average height, I really only have one way to find average height, and that's the average value function of the height. So I'm going to go there. To do this, though, I will need to find two things. I will need the height equation and the A and the B, or the time when it's in the air. So working from gravity, acceleration due to gravity is negative 32. Velocity is the antiderivative of acceleration, so that's negative 32t plus c. Given that it was, God, what's the question I'm on? What am I doing? 6. Given that this was dropped implies what? That at time 0, the velocity is 0. So the velocity is negative 32t. Great. Now I can move on to getting the height. Height is the antiderivative of velocity. The antiderivative of negative 32t is negative 16t squared plus a new constant. The initial condition I have is that at time equals 0, the height is 576. From that I get that height is negative 16t squared plus 576. I've got my height equation. I'll be able to at least do the integral of that. That's a good start. Now I need to know what are the limits of time where it's in the air. To find when it's in the air, well, I know time 0 is when it starts being in the air. How do I find when it stops being in the air? When it hits the ground. And when it hits the ground, what do you know? Velocity or height? Height is 0. Height is 0 at 576 over 16 square rooted plus not negative, right? Is that going evenly? 32. Does that go in 36 times? So that's 6. Feels like it's in the ground for 6, or in the air for 6 seconds. Okay, so now we're ready to go. Average height is 1 over 6 minus 0 from 0 to 6 of the height function. Integrate that to rock and roll. Okay. 4, question on 4. Now integrate. Okay. Just so we're clear, when I do questions and I say now integrate, I actually expect you to still integrate. I'm getting 2 students turning it in with now integrate on the page. I speak to I mean for you to integrate. Number 4. Number 4, 1/2 to 3 halves. Okay, this is good new problem. Find it at rest. What does at rest imply? Velocity is 0. Okay, so I need to set the velocity equation equal to 0, which requires trig skill. The 2 pi doesn't matter. Sine is 0 when the angle is 0 or pi or 2 pi or 3 pi, etc. Right? That's when sine zeroes out. So that would imply time of 0, 1, 2, 3. In the time interval they're talking about, the only one that really is applicable is 1. Yeah. Okay. Find the total distance traveled in the negative x direction. All right. So I know distance is the antiderivative of the velocity, but I need to know when it's traveling in the negative x direction to do that. So now I need to probably do a little bit of a velocity sign test. At 1/2 or this side of 1, sine seems like it's positive, and on that side of 1, sine of 3 pi over 2 is negative. So it's moving in the negative x direction from time 1 to time 3/2, right? Now, if it's moving in the negative x direction, then in terms of the absolute value, wouldn't that be then the opposite of whatever v is? Yay? So if I need to integrate 1 to 3/2 of the opposite, I'm just going to put the negative out front if you don't mind. 2 pi sine of pi t. Cool? Good chance to use some review. Okay, it's got a function within a function, so we're going to use some. If I let u equal pi t, then du is pi dt, which means dt is du over pi, and when x is 1, u is pi, and when x is 3/2, u is 3 pi over 2. So the integral becomes negative pi to 3 pi over 2 of 2 pi sine of u du over u over pi. Yay? Are you with me? Okay? Pi's thankfully divide out nicely. What is the antiderivative of negative 2 sine u? Negative or positive 2 cosine u? Positive 2 cosine u from pi to 3 pi over 2. That's 2 times 0, that's 2 times a is 1. What?
There's a negative out.
Yeah, but the antiderivative is negative.
Of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
The negative, the antiderivative of sine is negative cosine. Okay. 4, is that 4? 20. I want the worksheet turned into. I'll grade it myself and we'll go over questions tomorrow. It is due today.
Attention art students, please come and get your word art sculpture on display in the library as soon as possible. Please check with Ms. Porter or Ms. Aaron. Thank you very much.
This is negative u. So secant is the derivative of cotangent with the negative.
Join Devlin's only nationally competitive sports team.
16?
20 seconds and
16, anybody?
8 to 11 free girls. No experience needed. Get to go to Disney World for 5 days. Contact Hartford Long for more details.
I'm just gonna put them on.
Come to a trial at the classic Masquerade Ball on Saturday, March 9th at 7 p.m.
X-axis or y-axis? Y-axis. Y-axis is a lot harder. So, let's think about our choice of variables. Y would stink because it would be two integrals. Y is bad, two integrals. Instead, use X. If I use X, then it's always the same upper and the same lower. X is better. If I use X, then it's one integral. It's a shell. So then what's the radius, what's the height? Radius is just... Yep. I did? Did I say that? Do that, alright, well... Alright, if I gotta use washers, then it's gotta be Y. But you're gonna need two limits of integration, or two regions. One, big R is always 2, and little r is always 1. And that's from 1, 0 to 1. The upper limit is from 1 to 2.
Art Month competition back in November. Her piece won top honor for the state of Colorado. Her work will be turned into a flag to represent our state at the National Art Conference, which will be on display.
Take it back. It wouldn't be 1 to, it would be 0 to a half, wouldn't it? At 2, this would be a half. And then when the upper region, it's from a half to 1. And its curve, which is 1 over y squared for the big R, minus 1 for the integral. Man, that was me. Why would I do that? That's why we do the show, so we don't have to do that. All right. Perfect, guys. Have a good day. Make sure I get both today. See you. Bye-bye.